Hello everyone, nice to meet you. I'm ZHAOHAO Mai. Here's the PPT presentation of ECE201C final project. My final project is spice-driven table-based high sigma modeling. The object of this project is to reduce the times of calling spice to estimate the failure probability of high sigma cases of reading functionality of SRAM circuit because if I feed 1 million Monte Carlo data in his spice, it's expensive. At the same time, I need to implement important sampling method and probability collective method to help me reduce the sample data for sweep data of spice simulations. Here is the brief of description of approaching methods of the final project. First, I use 1 million Monte Carlo data samples and output data sample as initial inputs for MATLAB program. Second, I applied important sampling methods to find the new mean and new sigma of each dimension. In other words, I shift their means and sigma variables for new data sampling for spice. Then I write the new sample data as sweep data for spice. I run the spice to do the SRAM circuit simulation and get the voltage of bit line and store their values in output. With spice output, I can find failure probability and FOM. At last, I need to check the FOM to ensure its accuracy rate can reach 90% or more. If not, the step 2, 3, 4 needs to be repeated. Otherwise, I will plot the data. Here are two plots of failure probability of high sigma cases in different number of samples per iterations. The value of failure probability stays around 0.01%. For the left plots, the process converge in a few iterations, hence it has fewer points of failure probability of high sigma. However, for the right plots, the process converges in a more iteration, hence it ends up with more points of failure probability, and each probability has slightly different with from each other. So that's why they looks like a jumping everywhere in the plot. Here are two more failure probability versus iteration plot with the same samples per iteration. In this case, it is 38. I can see the trend of failure probability of high sigma cases. The trend is that as I run iteration as many as possible I can, the value of estimated failure probability gets closer to 0.01%. In other words, as the iteration goes infinity, the estimate failure probability is infinitely close to the 0.01%. Here's my observations of the plots above. With different situations and conditions, the failure probability of high sigmas remains at 0.01% or stay around 0.01%. The worst case is that it fluctuates around the 0.01%. In other words, it shows that the estimated failure probability of high sigma cases works well, and simultaneously It tells me that reducing times of calling spies makes little differences in calculating failure probability of high sigma cases. Hence, the method works fine, and I think reducing in non-essential cases and low spice work will not affect in calculating failure probability of high sigma cases. Here is the summary and conclusion of the PPT presentation from the project. With the important sampling method and probability collective methods, I have a good estimation of failure probability of high sigma cases of SRAM circuits, and their value are close to theoretical values 0.01%. In conclusion, I can reduce the time of calling spies from 1 million to 30K or 50K. It depends on the sampling numbers you use for every iterations, and simultaneously I can capture the good estimation of failure probability of high sigma cases of read functionality of SRAM circuits. The previous work shows what I said. And thanks for or listening to my presentation. Thank you very much.